Bismillahirrahmanirrahim. In the name of Allah, the most gracious, the most merciful. Hi everyone. I hope you are doing well. This is, inshallah, a quick revision on chapter 6. Okay. Here we are not interested in talking too much about the theoretical points. Okay. So we will give an overview revision, inshallah. Number one, the first term to talk about is the momentum. What's meant by the momentum? The momentum is the amount of movement, amount or quantity of movement. Okay, I'm not interested in repeating this, but the formula of the momentum, P equal mass times velocity. Mass times velocity. Let's remember the following: to extract or to conclude the factors that are affecting momentum, we will extract them from what? From the equation itself. Okay, the equation says P equal mass times velocity. So the first factor is mass. The second factor is velocity. P and M are directly proportional to each other. Remember the following, because they are on the same line and there is an equal sign between them. Remember the following. Okay, but I have to say P is directly proportional to M at constant what? At constant velocity. What does it mean? It means as mass doubles, the momentum doubles. As mass halves, the momentum halves, and so on. Okay, and remember that means also if we plot the relationship or the graph between the momentum and the mass, the relationship will be a straight line, starts from the origin point, and the slope will be velocity. Well, okay, this is in constancy, in the case of constancy of velocity. P is also directly proportional to V, and so on. What about the measuring unit? The measuring unit, as we said, it's derived from the equation. Mass is measured in kilograms, V is measured in meter per second, so kilogram meter per second is the measuring unit, or in other words, the SI unit of momentum. Well, let's talk about the impulse. The impulse has two definitions. The first definition is it's the change of momentum, or the change in momentum due to the action of a certain force. Okay, this is derived from the what we call the impulse momentum theorem, because the impulse momentum theorem tells us the following. It says the impulse equal what? Equal the change in momentum. The impulse equal the change in momentum. It's just too short definition. Yeah. Well, so the momentum has two definitions. I momentum, two formulae or formulas. I equal delta P equal change in momentum. P final minus P initial, because the change in any quantity is its final value minus its initial value. Well, by substituting, we will find that it's equal to mass times final velocity minus initial velocity. Mass is a common factor. From here, we can get the measuring unit of impulse as kilogram times meter per second, like the momentum, because it's change in momentum, so it has the same measuring unit as the momentum. But from the second definition, the impulse is the product of the average force, or the force times the time of its action. Okay, the time of its action. So it equals force times delta T. So from here we can get another measuring unit. The force is measured in newtons. The delta T is measured in second. They are multiplied times each other. So the measuring unit will be Newton times second. In other words, I can say the following. Hey everyone, be careful. As we proved these two measuring units are equivalent. They are equal to each other. Kilogram meter per second equal Newton times second. Well, and now let's have a quick example on this. Okay, if we have a ball like this is a racket ball, for example. This racket ball has the mass 2 kilogram. It's moving towards a wall with a velocity of 10 meters per second to right. Okay, it hits the wall and it recoils, or let's say bounces off with final velocity 10 meters per second. Okay, the required is to find I. The question someone may ask me, Mr. From where can I get I? From the first formula, which says I equal what? I equals m times final velocity minus initial velocity, or from the second formula, which is the impulse momentum theorem. The first one is the impulse momentum theorem. The second one is F times delta T, from where the answer is let problem leads you. The answer is let problem leads you. What does it mean, mister? It means if you want to find to know what the equation you would use, extract the givens. The givens here are: number 1, VI; number 2, M; number 3, VF. But here, be careful. VF here is a negative. Why? Because it's opposite to the initial velocity. And the first thing to be done in solving any problem of momentum, or any problem of collision, or any problem of splitting object into two parts is to assume certain position, for example, to right, okay, or up as the positive, certain direction as the positive direction, and any direction which is opposite to it will be negative when you substitute its value. Okay, so we will use I equal mass times final velocity minus initial velocity. Mass is 2, final velocity is negative 2, initial velocity is negative 10, initial velocity is 10. There's negative sign or minus here, so the answer will be negative 40. By the way, I want you to look well. If you forget this negative, what will happen? It means the final velocity would be what? It will be what? It will be positive. Positive 10 minus negative 10, it will be 0. So it will be so silly to do such a mistake. I hope you understood this part, and inshallah in the next part we will talk about the different formulae of law of conservation of momentum. Thank you everyone. Assalamu alaikum wa rahmatullahi wa barakatuh.